Hello everyone, let's practice some questions related to dynamics. Please subscribe to the channel and share it with your friends. In this question, there are two objects of masses, equal masses, same speed, moving in opposite direction. Whenever it's written elastic collision, you cannot say that the object will stick together, because if the objects stick together, the relative speed of separation will be zero. And as you can see, the relative speed of approach is 2v, so relative speed of separation cannot be zero, so option A cannot be the answer. Kinetic energy before collision of object A, half mv square, object B, half mv square, so the kinetic energy of the system is mv square. If the kinetic energy of the system before collision is mv square, so kinetic energy after collision will also be mv square, so option B is correct. Option C is incorrect because it's written kinetic energy before impact is 0, which cannot be possible, because if this is the case, the object will not collide. The total momentum of the system before impact is 2 mv. As you can see, the momentum of object A is positive mv, momentum of object B is negative mv. So the total momentum of the system is actually 0. And in option D, it's written it's 2 mv, which is wrong. In this case, there are two objects and it's written the object explodes. Whenever it's written object explodes, initial momentum will be 0. So 0 plus 0 is equal to m1v1 plus m2v2. So m1v1 minus m2v2, minus because the objects are moving apart, opposite direction. So m1v1 is equal to m2v2 and v1 upon v2 is equal to m2 upon m1. So option B is correct. In this case, the two objects A and B before collision moving in opposite direction. After collision, they move in same direction. So opposite add and same subtract. If the collision is elastic, their result will be equal. So UA plus UB, which is opposite, VB minus VA, which is after collision relative speed of separation, they must be equal. In this case, there are two objects of equal masses moving in opposite direction with speeds 60 and 30 respectively. According to the situation, 60m minus 30m is equal to mv plus mv. As it's written, they stick together. Stick together means move in same direction with same speeds. So mv plus mv is actually the momentums of the objects after collision. So 30m is equal to 2mv and v is 15 meters per second, centimeters per second. In this case, force F is applied on an object of mass 4m. X is of m, Y is of 3m, so the system is of 4m. F is applied on the system, which is of 4m. So you have to find out the magnitude of force exerted by block X on block Y, which is actually equal to the force applied by block Y on block X. On block Y, the force is actually 3 times the total force. 3 parts of the total force. It's because more mass means more force. So object Y is more massive, so it will apply more force on object X. 3F upon 4 is the answer. In this case, there are two objects of masses 2 kg and 4 kg moving in the same direction with speed 8 meters per second and 2 meters per second. After collision, they stick together. So according to the condition, 8 times 2 plus 4 times 2 is equal to 2v plus 4v. So 24 is equal to 6v, v is equal to 4. 4 meters per second is the answer. Molecule of mass m traveling horizontally with speed v, speed u, and after collision the molecule rebounds with the same speed. So initially its momentum is mu, positive. After collision, momentum becomes mu, negative. So the change in momentum is the difference between the two. So final momentum is minus mv, initial momentum was mv. So minus mv minus mv is actually 2mv. So minus 2mv is the change in momentum. Minus is actually showing that the direction is opposite. So minus 2mu is the answer. This is the application of Newton's third law. The force applied by object A must be equal and opposite to force applied by object B on object A. This is actually satisfied by option B only, while in option A, there are three objects discussed. Weight is between mass and earth, and the third object is ball and the ground. So there are more than two objects in this case, so option A is incorrect according to Newton's third law of force pair. Similar is the case with option C and D, so B is the answer. In this case, there are two objects of masses 20,000 and 900 with speed 20 meters per second towards right, 30 meters per second towards left, and you have to find out total momentum. So momentum of object A is 400 kilonewton second. Momentum of object B is 27 kilonewton second, but negative. So when you will add them, the answer will be 373 kilonewton second. Two objects of masses m and 3m move in opposite direction, stick together, which means inelastic collision according to law of conservation of momentum. M times 2v is minus 3mv is equal to 4mx. I have taken x as the final velocity of the system after collision because they have taken v as initial velocity. So final velocity of the system after collision is actually minus v upon 4. Here minus is actually indicating direction. They have asked you about speed, so you will write v upon 4 magnitude only. In this case, there are two objects of same masses. Object A is moving towards right, object B is stationary. You have to write down three equations, one for momentum, the second one for kinetic energy, and the third one for relative speed of approach for the system before collision. Now if the system has elastic collision, the one out of these four options will satisfy these equations. So we will check each option for these equations individually. I'll check for option 1, equation 1 and equation 3. According to option A, the relative speed of separation is 0 because they are moving to the same direction with the same speed, which means relative speed of separation is 0, and this is not satisfying equation 3. According to option B, the total momentum of the system after collision is minus mv, and it was mv before collision, so option B is also incorrect. According to option C, the momentum before collision of object A is minus mv, of object B is positive mv, so the total momentum is 0, and of course this is also not the case because this is not satisfying equation 1. Momentum must be conserved. Now option D is actually the right answer. It will satisfy equation 1 and equation 3. Momentum after collision is mv because object B moves towards right, and relative speed of separation is v because the object X is stationary and object Y is moving towards right with speed v. So this satisfies equation 1 and equation 3, so option D is correct answer. Two objects, cannon and cannonball, initially at rest. After collision they recoil, which means they move in opposite direction. So according to law of conservation of momentum, 0 plus 0 is equal to 1000 times 5 minus 10 times v. Speed of cannonball is unknown, so v is actually 500. The gradient of momentum time graph is force, so we will find out the force by the gradient, and the gradient is actually non-zero between t2 and t1. So according to the concept of gradient, y2 minus y1 upon x2 minus x1, so p2 minus p1 upon t2 minus t1 is the force, but they have written p1 minus p2. This will give you the same magnitude, but direction is actually indicated by the sign. So option B is correct because p1 minus p2 or p2 minus p1 will give you the same magnitude. In this case, the two objects collide and stick together, so we have to find out the total kinetic energy after collisions. Let's first find out the speed of the system after collision. According to law of conservation of momentum, 2 times 4 initial momentum of this system plus 4 times 1 initial momentum of this system is equal to total momentum of the system after collision. Stick together, that's why I have written 2v plus 4v, same speed. So v is equal to 2 meters per second. This speed is actually the speed of the system after collision. To find out kinetic energy of the system after collision, half mv square. M is 6 and v is 2, so 12 joule is the answer. The object is accelerating, which means forward force is greater than backward force. So FF is greater than BF. FF minus BF is equal to RF. Forward force minus backward force is equal to resultant force. So 2000 minus X is equal to MA, 750 multiplied by 2. X is found to be 500 Newton. In this case, there are two objects. We will write two equations, one for momentum and one for relative speed of approach, and the correct answer will satisfy both equations. So momentum before collision is mu and relative speed of approach is 2u. So these are the two conditions, and the correct option must satisfy these two conditions. The momentum after collision must also be mu. The relative speed of separation must also be 2u. So let's check for option A. Momentum of object A after collision is minus 2mu upon 3, and of object B is minus 5m plus 5mu upon 3. Minus for left, positive for right. So if you add these two momentums to find out the total momentum of the system after collision, you will get mu, which is actually condition 1. So condition 1 is satisfied. Now to check for relative speed of separation, u upon 3 plus 5u upon 3, because they are moving in opposite directions, so you will add, because opposite add in relative speed of separation. So it will give you 2u, which means both conditions are satisfied. So option A is incorrect. A is correct, while option B, C and D will give you incorrect answers for either 1 or 2. In this case, there are two objects of masses m and 2m, and you have to find out the ratio of their kinetic energies. Let's first find out their speeds after collision. According to law of conservation of momentum, 0 plus 0, because the object explodes, initial momentum is 0. So m1 v1 is equal to m2 v2. mv1 is minus v2 is actually equal to mv1 minus 2 mv2. So mv1 is equal to 2 mv2, which means v1 is equal to 2 times v2, which means velocity of object A is 2 times velocity of object B. Now if you find out the kinetic energy of object X, half mv square, m times its speed v1 square. v1 is actually 2v2, so I have written 2v2 instead of v1. After solution, you will find kinetic energy of X as 2v2 square. Now to find out kinetic energy of Y, half m2v2 square. m2 is 2m and v2 is v2 square, so you will find kinetic energy of Y as mv2 square. To find out the ratio of X and Y, kinetic energy of X and kinetic energy of Y, kinetic energy of X is 2mv2 square and kinetic energy of Y is mv2 square, so you will find out the value as 2 upon 1. In this question, the object of mass 2m with velocity v moving towards right collides with the wall and rebounds. You have to find out a possible change in momentum. In this case, we will use elimination method. Let's say if option A is correct, checking for option A. As it's written that momentum before collision is 2mv and the change is mv, which means after collision the momentum must be positive mv, and this is not possible because momentum before collision was positive, so momentum after collision cannot be positive. So option A is incorrect. Option B, initial momentum is 2mv, change in momentum is 2mv, so the final momentum must be 0 to satisfy condition B, but final momentum cannot be 0, because if option B is correct and final momentum is 0, which means the object is actually sticking on the wall, and this cannot be the case as it's written the particle rebounds along the same path. So option B is also incorrect. To check option C, 2mv minus X is equal to 3mv. Now To make the change in momentum 3 mv, the final momentum must be minus mv, and this can be the answer because minus is indicating that the object is moving in the opposite direction, and the velocity is actually v upon 2 because the momentum was 2 mv, so velocity is v upon 2, which means final speed is less than initial speed, and it's written that the collision is inelastic, which means kinetic energy after collision will be lesser. If you check option D, you will see that after collision the speed is more, and this cannot be the case because the collision is inelastic. According to law of conservation of momentum, if you solve this, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 square. Object A is moving with speed v while object B is stationary, so mv plus 0 is equal to, they stick together, so it will become 2mx. X is the final speed of the system, so x is equal to v upon 2, which means after collision the two objects move with speed v upon 2. To find out kinetic energy, half mv square, mass is 2m and speed is v upon 2, so v upon 2 square, it will become half mv square upon 4. So option A is correct because initial momentum was mv, final momentum must also be mv because momentum of the system is also is always conserved whether it's elastic or inelastic collision. Kinetic energy is found to be 1 upon 4 mv square, so option A is correct. Frictionless ice rink surface, right? So there is no resultant force, so there is no change in momentum, and after collision the momentum of the system will change, and if it was positive before collision, after collision it will be negative. Option B is not satisfying frictionless surface, because if the surface is frictionless there should be no change in momentum. Option B is showing change in momentum, and option C is also showing change in momentum, which is actually negating frictionless surface. Option D is showing that momentum has changed but the direction has not changed, which is not possible because after collision the object moves in opposite direction, so the momentum, if it was positive before collision, it must be negative after collision. So option D is also incorrect. Option A is correct because it was positive and it was negative after collision. In this case there are two forces acting vertically and two forces acting vertically upwards while one force is acting vertically downwards. 4 Newton force and 3 Newton force are making angle 37 and 53 degree with the vertical axis, so we will simplify, or we will resolve these forces to find out the vertical components of these forces by making vector triangles as I have drawn for 4. So I have drawn vector triangle for 4 Newton force. This force is horizontal, this force is vertical, so vertical component of 4 Newton force is actually 4 cos 37. Similarly, if I solve for 3 Newton force acting at 53 degree with vertical, it will become 3 cos 53. So 4 cos 37 and 3 cos 53 are the two forces acting vertically upwards, which is 3.195 and 1.805. So these two forces, 3.195 Newton and 1.805 Newton forces, are acting vertically upwards, which means the total force acting vertically upwards is 5 Newton and total force acting downwards is 12 Newton. Resultant force vertical is 7 Newton, and to find out acceleration you divide resultant force by mass. A is equal to F upon m. So 7 is divided by 1.2, so answer is 6 meters per second square vertical acceleration. Two objects, one of mass 2 kg, it is placed on a horizontal surface. The weight of this object and the normal reaction force are balanced, so there is no vertical force acting on 2 kg mass, but there is an horizontal force acting on the right hand side because of 1 kilogram mass. The force applied by 1 kilogram mass is actually 1 multiplied by 9.81, which is W is equal to mg. So resultant force on the system is 1 multiplied by 9.81, which is due to this force, divided by mass of the system, which is 3. So the acceleration produced is 3.3. To find out the final velocity by which the system will hit the floor if the distance is 0.5, according to the equation of motion, 2as is equal to v square minus u square. V is unknown, u is 0, a is 3.27 and s is 0.5. You will find v as 1.8 meters per second. In this case, the block is stationary, the bullet is moving, and the speed of the bullet is actually 200 meters per second. Its mass is 5 gram. So total momentum of the system before collision is 1000, and after collision they stick together because it's written in beds. So 5 multiplied by 200, which is momentum of the bullet, plus 0 is equal to 100 v, because the mass of the system is now 100 and it is moving together with the same speed. So 100 v is equal to 1000. So v is equal to 10 meters per second. To find out the height it will gain, so the system will rise with a speed of 10 meters per second. At the maximum height the speed will be 0. So u is 10, v is 0, a is minus 9.81, s is unknown. By the equation of motion you will find out s as 5.1 meters. The gradient of momentum time graph is force. The gradient is non-zero between 4 and 5.5 seconds. To find out force, you will find out gradient delta p upon delta t. So 300 upon 1.5 is actually resultant force, which is 200 Newton. In this case, wind of speed 33 meters per second, density 1.2 kilogram meter per meter cube, area of the wall is 12 meters square, and the speed is reduced to 0. So F is equal to delta P upon delta T, which is m delta V upon delta T. Mass is density multiplied by volume. Volume is area into length. Area is 12, length is 33 meters, because we are solving it for 1 second, so distance traveled is 33 meters. Volume of air is 396 meter cube. Mass is 1.2 times 396, which is 475.2 kg. To find out resultant force, mass multiplied by change in velocity. Change will be 33 minus 0 divided by time, which is 1 second. You will find it as 15681, which is 16,000 Newton. That's all for this video. I hope you like the video and these questions will help you understand the concepts which are important for solution of momentum. Please like the video, please subscribe and share it with your friends, and please give the feedback. Thanks for watching.